Okay, let's just look at a couple more examples of solving quadratic inequalities. So let's look at example E, x squared minus 4 is less than 0. So remember, the first thing I want to do is kind of think about this as just an equation, a quadratic equation. X squared minus 4 equals 0. Then I'm going to use this equation to find the x-intercepts. So you can solve this either by factoring, or you can solve it by taking the square root. So maybe just to see a little bit of a different method, I'll solve it by taking the square root. So first I'm going to bring the 4 to the right side of the equation, and then I'm going to take the square root of both sides. So I get x equals positive and negative 2. Don't forget that positive and negative. Okay. So 2 and negative 2 are going to be my x-intercepts. So as I start thinking about graphing this or sketching a rough graph, I'm going to have these two x-intercepts at 2 and negative 2, and then I know my graph is opening up because my a value is positive. So it's going to look something like that. And then I am looking for all the places where this function is less than 0, so smaller than 0. So it's going to be all these values between 2 and negative 2. So let's jump down to my number line and sketch and kind of translate this blue XY graph to just a number line. So since I have a less than sign but not a less than or equal to sign, I'm going to draw open circles at my two x-intercepts, so 2 and negative 2. And then I'm going to shade in the part between those two, because it's along those values that my x values are less than 0. Then I'm going to translate this into interval notation. So it's going to go from negative 2 to positive 2. And I'm going to have parentheses instead of brackets because my circles are open circles. Okay, example F is a really important one for us to look at because it doesn't have a 0 on one side of the inequality. So the first thing we want to do is we just want to make this inequality so that one side of it is a 0. So I'm going to add 9 to both sides. So I have x squared plus 10x plus 9 is greater than or equal to 0. And the reason I want to do that is because now my equation is equal to 0, so when I start looking at my graph, I can still look at just values that are above or below the x-axis. So now I want to go ahead and try to solve this quadratic. So I'm going to start just by factoring it. So now I can factor it into x plus 9 and x plus 1, because 9 times 1 equals 9, and 9 plus 1 is equal to 10. Okay. And then I know that these two factors are going to give me the x-intercepts of x equals negative 9 and x equals negative 1. So when I sketch this on an xy plane, it's going to look something like that. My parabola is opening up because my a value is positive. So I'm going to have something like that. And again, all we care about is a rough sketch where your parabola is going the right direction and it has the right intercepts. Now looking at my inequality, I want to know where is my function bigger than 0. So it's going to be all these values that are above the x-axis. Okay. So let's go ahead and translate that down to my number line. So I'm going to have solid dots because I have a greater than or equal to sign. So I'll draw them at negative 9 and negative 1. And then if you look back at my graph, I'm looking at the values that go far to the right and far to the left of those two values. And then in this case, since I kind of have two chunks of solutions, two chunks on my number line, I'm going to write two different interval notations, negative 1 to negative 9. And then I have negative 1 to infinity. And don't forget to put that nice union sign, which looks like a U, between those two pieces. All right. The next four examples are all dealing with the exact same quadratic, x squared minus 4x plus 4. So I am going to help you guys get started on these, and then I want you guys to go through and try to practice them on your own. So what I'm going to help you guys get started with is finding the x-intercepts, or finding those points that are going to land on your number line. Okay. So I'm looking at this equation. Well, first I'll make it an equation right now. It's an inequality. And if I want to solve that, it's in standard form, so I can either factor it or I can do the quadratic formula. So if I could factor it, I would be looking for two numbers that multiply to positive 4 and add up to negative 4. Now luckily I know two numbers that'll do that, x minus 2 and x minus 2, because negative 2 times negative 2 is positive 4, and negative 2 plus negative 2 is negative 4. Okay. So once I have this solved, then I know that my x coordinates are going to be x equals 2. Okay. So it's kind of confusing with this one because we have the exact same x value. So let's sketch a graph of this and see what it'll look like. I know that my only x-intercept is going to be here at x equals 2, and my parabola is opening up. So it's going to look something like this. Okay. So that's what my graph is going to look like actually for g, h, I, and j. So let's just go ahead and highlight on this parabola the solutions for g. So this inequality is saying that I want it to be greater than 0. So I want to look at all these values that are bigger than 0, which is, it looks like it's all the values, but it's actually all the values except for the one place where the graph actually touches the x-axis and is equal to 2. Okay, so you can't forget that if your graph is just going to touch right there, it means that right at that point, your equation is equal to 0. So when I want to translate this to the number line, it's going to look like I've highlighted the whole number line, but I want to make sure I have an open circle at 2. Because my inequality says I only want the values that are bigger than 0. And at 2, that's when my equation is actually equal to 0. So to write this in function or an interval notation, it would go from negative infinity to positive 2, and then go from 2 to positive infinity. And I put these open parentheses on both of the 2's, because that means that I'm going to get really, really close to 2, but I'm not going to include 2 in my solution set. Okay. So with h, again, I've got the exact same parabola, so I'm just going to go ahead and sketch that again using what I did in g. Okay. Now as I think about highlighting solutions here, I want all the numbers that are greater than or equal to 0. So now I'm going to include everything that's above the x-axis, and I'm going to include that place where the function touches the x-axis and is equal to 0. So this one's kind of cool because at every point on my graph, my function is either greater than or equal to 0, which means that on my number line, I'm going to include everything. There's not a single value on the x-axis that doesn't give me 0 or something bigger than 0. So as I write my interval notation, it means I'm just going to include everything from negative infinity all the way up to infinity. Okay. All right, let's jump down and do I and j together. If you feel confident, like you can finish these on your own, go ahead and hit pause, do them on your own, and then jump back and make sure you did it right. So I'll go ahead and sketch the same parabola because I'm dealing with the same quadratic. So in this example, I'm looking for all the values where my function is less than 0. So I'd be looking for anything over here beneath the x-axis that's going to be less than 0. In this case, there aren't any values that are beneath the x-axis, so I have nothing to highlight, right? There's not a single point on this graph that I could point to and say, right there is where the graph is less than 0, okay? Which means that I can't highlight my number line at all. And there's no interval notation. So I'm going to say there's no solution. There are no x values that work for this inequality. Okay. All right, let's do our last one. What happens when I want to know, what happens when I'm looking at this graph and I want to know when it's less than or equal to 0? Okay. So we already decided that there are no points where this graph is less than 0 because all the points are either on or above the x-axis. We do, however, have one point where the graph is equal to 0, and that's right here at my x-intercept. And that is the only place where my function is less than or equal to 0. So as I come down to my number line, I'm just going to be able to plot one singular point. That's all I can do. There's nothing else I can highlight. And then as I write my solution, there are a couple different ways you can write it. You can just write it as x equals 2. Or if you want to write it in interval notation, you can write it from 2 to 2 with those closed brackets.